In this video, we're going to learn about confidence intervals. We're not going to necessarily learn how to build them yet, but we're going to learn some definitions and just kind of some basic ideas. First, a little review. From past years, a quiz is thought to have an average score of 20 with a standard deviation of 3. A sample of 60 is taken. What's the probability that this has an average score of over 21? Well, let's start with our conditions. We're going to assume that 60 is less than or equal to 1/10 all test takers and takers. And condition 2, well, our sample size is greater than or equal to 30, so we can by central limit theorem, we can use the normal curve for this problem. All right, so it is normal, the distribution of sample means, with a mean of 20, right? We're centering this around 20. And the deviation was 3, but of course this is the distribution of means, so we divide it by the square root of n. And of course we want to know 21. So there is our probability. So pretty low. A sample of 60 you wouldn't expect to have a mean that much higher than 20. Okay, a simple random sample is taken of 3,000 high school juniors about college aspirations. 42% of those sampled say they plan on going to a four-year college. From this, the company conducting the survey says that they have built a 95% confidence interval that says between 40 and 44% of all juniors plan on going to a four-year college. So a couple of terms. The first, a point estimate. A point estimate is the statistic that you got that you built your interval around. So the statistic that that's estimating our parameter. So for us, it's this number right here. It's the actual percent of students. Now we usually use proportions, so I'm going to use 0.42. The margin of error is the number that takes us from our point estimate of 0.42 to the ends of our interval. So our margin of error here is 2% or 0.02. And our confidence level is this number right here. Okay. Now I want to talk about the meanings of some more of these things, but I first just want to show you that this is a really this is a very common confidence level and confidence interval type thing to make. And I actually have an example here. This was taken from what's called the Minnesota poll. It was published by the Star Tribune. And you can read the whole thing, but what I really just wanted to highlight was it talks about how it was conducted. It says the results of the poll will vary by no more than 3.7 percentage points. So that's our margin of error. Okay. Of error, I'll abbreviate. And then it says plus or minus from the overall population 95 times out of 100. So there's your confidence level. I'll just even put an arrow down to confidence level. Okay, so whenever you read a poll, this is usually kind of the fine print at the bottom. So you can see kind of their methodology for how they constructed. Let me talk a little bit more about the meanings of confidence interval and confidence level. These are two definitions to commit to memory. In terms of the AP exam, it really is one of the most tested definitions and definition differences. And I'm going to show you some examples of how this has been tested. A confidence interval is what we were kind of just dealing with. A confidence interval of whatever percent, the previous example was 95, so maybe I'll fill that 95% in for C, means that once we've conducted and built, we are 95% confident that the interval we get between blank and blank, so in our previous example it was 0.4 and 0.44, 40 to 44%, will capture for our previous example, population proportion that plan on going to a four-year college. Okay, so let me say that whole sentence. We are 95% confident that the interval from 0.4 to 0.44 captures the population proportion that plan on going to a 4-year college. So this is building an interval and saying, I believe it is between these values. Now, that's interval. Let's talk about level. So if we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter. So this is a more broad kind of methodology type definition, and it really has to do with not the actual interval. You know, I didn't mention anything about 0.4 and 0.44 because what this is saying is if I sent out 100 people to do the same thing, they all went out and interviewed 3,000 high school students, they would come back 95 out of those 100 people that I sent out to take surveys. 95 of their intervals would capture the actual parameter. Okay, so, and that's why it doesn't mention the 0.4 and 0.44 here. It's because if I send lots of people out to do it, they'll all get different intervals based on their own surveying. But I would expect that 95% of those intervals that come back to me will capture the actual parameter. So one big thing to notice is that the interval is like a one-time thing. It's like a personal, like I built an interval, here's what I got. The level is much broader. It says if we repeated this and did it over and over again, 95% of those new intervals would capture the parameter. Let's look at how this is tested on the AP exam. 2002. A simple random sample produces a sample mean X bar of 15, a 95% confidence interval for the corresponding population mean. So you can see it's from 12 to 18. Which of the following statements must be true? First, 95% of the population measurements. Well, that is false. A 95% confidence interval is all about, in this case, saying I'm 95% confident the mean is between 12 and 18. That has nothing to do with the parent population. I don't know anything about that. I am only pretty sure of where I think the mean is. Letter B, 95% of the sample measurements. That is false as well. I don't know anything about my sample. I only know about where I believe the mean is. If 100 samples were taken, 95 of the sample means would fall between 12 and 18. This is kind of edging towards talking about confidence level, but the minute they start talking about this and the actual numbers and actual interval, it falls apart. Okay? And I guess how you would finish this statement to be correct about level is if 100 samples were taken, 95% of the, I'll even cross off a little bit more, confidence intervals would capture the mean. Okay, it has nothing to do with the actual 12 to 18. It means we took 100, we did it 100 more times, and they all got their own interval. My favorite answer or incorrect answer is D. It says the probability that the sample mean is between 12 and 18 is 0.95. Well, the sample mean was 15. The probability it falls between 12 and 18 is 1. It's right in the middle. We based our interval off of it. Finally, it's obviously got to be E, but I want you to think if mu was 19, so if the real mean was 19, then the X bar would be unlikely to occur. And that is the answer. We're 95% confident that the mean is somewhere between 12 and 18. That means we only thought we had a 5% chance of missing it, and we did. So it's unlikely that the 15 we would have gotten 15 if 19 was the real mean. 2012, a large sample, 98% confidence interval for the proportion of hotel reservations that are canceled on the intended arrival day is 0.048 to 0.112. What's the point estimate for the proportion? Okay, so the point estimate, remember, is what we got from the actual sample. It's the middle of our interval. So if we just found the average, that would be our point estimate. It is 0.080. The point estimate is the thing that comes in the middle because it's point estimate plus or minus margin of error is how we build our interval. Let's look at one more. This one's also from 2012, and this is a tricky one. A random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day. Which of the following statements best summarizes the meaning of this confidence interval? Okay. First, about 95% of all random samples of 50 students, this really feels like confidence level right here, from this population would result in, and then it falls apart. Then it falls apart by giving us an interval. Okay? So this is out. And again, to be correct, it would say, 95% of all random samples of 50 students would make an interval that captures the mean. It's not that we'd have the same interval. It's just that our differing intervals would get the mean. Part B, 95% of all random samples of 50 students from this population would result in a 95% confidence interval that covered the population mean number of hours. That is true. That is the meaning of a confidence level. I am going to, I'm going to keep moving because what really trips people up in this problem is it asks for interval, and B, this is the perfect definition of level. But let's keep going. Let's come back to B. A 95% of the students in the survey reported sleeping between, no, that's wrong. An interval is all about figuring out where the mean is, not where the sample students are. 95% of the students in the high school, again, no, that has nothing to do with the population at large. We're trying to figure out where the mean is. A student selected at random from the population sleeps between that and that, 95. No, it's not about what percent of the time they sleep. So the answer here is B because it is the only one that is a correct statement. And again, what's tricky is it's a correct statement about the level. But the others are all about kind of the broader population or our sample. The meaning of a confidence interval is we are 95% confident that the mean lies between 6.73 and 7.67. I'm going to say that one more time. We are 95% confident that the mean number hours of sleep for the population of this school is inside this interval. So make sure you understand the difference between the two, and we will continue practicing writing about intervals and levels.